your mic. Okay, so let's start the class with some questions. You guys have to answer in the chat box. Question 1, 2, and 3. Answer this, then we'll be moving ahead, moving further. Hope I'm audible properly to everyone.
Hello, sir.
Yes, Priyanka. And now you're audible, yeah. By the way, this is a necessary information. I have told you guys earlier also. Turn your cameras on in the class. To have a proper interaction, it is important. Okay. Also, your parents will be notified regarding this if you don't turn your cameras on in the class. Okay, start answering this. You know where you have to answer on Sohail, not on Mama Sohail Khan. Okay.
Sir, in chat box.
You're in the chat box.
Sir, which ID?
On this one.
Okay.
Abu, the answer for the second and third one you have answered, that is correct. But for the first one, you have answered it incorrectly. Yeah, Priyanka, yeah, your answer is correct, Priyanka, for the first one. Very good. Yeah, now it is correct. Okay. Abu, the second one, no, the answer which you have given, that is actually not correct. I didn't saw it earlier. It is false actually. Look, your Priyanka, your second answer is also correct. First one is correct, and the third one is also correct. Very good, Priyanka. See, all acids, all of them contain hydrogen in them, like whether you have HCl, whether you have HNO3, whether you have H2SO4, all of them have hydrogen in them, right? You can see, look at their formulas as well. In case of indigestion is happens when excess amount of hydrochloric acid is secreted by your stomach. So thereby it has to be neutralized by taking
But
antacids. What is the nature of antacids? Are they basic, neutral, or acidic?
basic.
Basic. So that will neutralize the impact of acid. Lactic acid is found in curd. Another thing you know that curd consists of a bacteria. Do you guys know about the name of a bacteria found in the curd?
No, sir.
That is lactobacillus. Okay. Kindly note this down in your copy. It will be helping you in in your school also. Generally, it will be helping you. Like you should know this fact. Write down that lactobacillus is the bacteria found in curd. Yep, done. Okay. All of you done. Hope all of you were done writing it.
Sir,
Yeah.
sir, I have one question.
Yeah. Sure.
Sir, like, what is,
Mm-hmm.
sir, what is, like, when, sir, you use turmeric and then you put inside base, it will become red,
Red.
okay?
Mm-hmm.
And then if you put inside acid, what will it become?
It will
Okay.
become
So
yellow.
it will retain its color when you mix turmeric with acid. So thereby what happens? It stays yellow. It will not change its color. Okay. Na?
Yeah.
Turmeric is a natural acid base indicator. When you mix when you mix basic substances into it, it changes to red orange in color in a basic substance. While in, as you said, Prinka, in the acidic solution, it will remain yellow. Did you guys noted this thing down?
Yes, sir.
Lactobacillus is a bacteria found in curd. Good.
Actually, our school told us to do this activity. Make and
Okay.
turmeric.
Sir, same.
Oh, oh, that's good. Hmm.
Yeah,
Here you can look at this, huh?
yeah,
The
and
color has changed over here.
acid add vinegar
Mm-hmm.
and a base side detergent.
Sir,
Detergent.
sir, for me, they have said you us to prepare it. You have to
Oh.
take turmeric, okay? You have to
Mm-hmm.
add water in it. Then you have to take like paper, and
Mm-hmm.
then we have to dip the turmeric in the paper. Then we have to take out that paper and then keep it for dry. Then after
Hmm.
that, we have to make strips of it, and then we have to put inside acid and base, and then we can see the difference.
Yeah, that can also be done. Basically, you can make make papered strips of turmeric powder. So you will take a solution of turmeric powder, then dip a strips of paper in it. So the paper will be absorbing the turmeric, and then later on you will be drying it. So that is also very interesting. That can also be done. Okay, no? So there are some substances in nature, or there are some synthetic substances. There are some substances in nature, or there are some synthetic substances that can be used to check whether the given substances acidic or basic. Why we have got such indicators? Because we cannot taste every object and find its nature. Because we know that some of acids and some of bases are very strong, and if someone were to touch it and taste it, it will be dangerous for their health, it will be harming them. That's why we take help of indicators. So indicators are basically the substance that can determine if a given substance is acidic or basic in nature, right now. So indicators basically indicate the presence of an acid or base in a substance by changing their color. Most commonly, they change their color. But later on, you will get to know that you have got some olfactory indicators also. Olfactory indicators that their smell will change. They, like if they are mixed into acids or bases, they might lose their smell, or they might retain their smell. So olfactory indicators are also there. So we have categorized acid base indicators as natural acid base indicators, and then we have chemical or synthetic acid base indicators also. In this image, what is this vegetable called as? That
Red
is
cat.
red cabbage. Very good. Or the examples you guys gave, like that of turmeric. Hmm. In fact, you guys know, apart from red cabbage or turmeric, litmus is also a litmus is also a natural indicator. Do you guys know that?
Yes,
Because since litmus is made from, yes,
lichen, like
lichens. Lichens are natural things now. So we have some natural indicators right now. Natural indicators will be including red cabbage, it would be turmeric, it would be a litmus paper, it would be a grape juice, in fact, is also sometimes used. Huh? That can also be used. Onion is also one of the natural indicator. Okay, no? Onion is also one of the natural indicator. Then visual indicators, like visual indicators, basically, it's not a very kind of a separate type of indicator. Basically, pretty much all the type of indicators that we are going to learn about, whether it be synthetic or whether it be natural, they will be giving you some visual indications, meaning that their color will basically change. So substances which are used to test whether a substance is acidic or basic are indicators which we are studying right now. Right now, these are the litmus strips, the red one and the blue one. So if you were to dip the red one, if you were to dip the blue one, for example, in the acidic solution, the color changes to red, and vice versa for red litmus paper. When it is dipped in the basic solution, it turns into blue color. Now, what happens if you were to dip the red litmus paper into acidic solution? There will be no color change. Or what if you were to dip a blue litmus paper in a basic solution? It will retain its color, no color change is observed. Are you guys getting it or not?
Yes.
The first two beakers in this, you have dipped a litmus paper. Litmus is basically, it's a naturally occurring purple indicator. Actually, it is in purple color, but later on it is dyed in blue and red color. Naturally, it is purple in color since it is made from lichens, and lichens are also purple in color. Right now, and it is available in the form of a solution also. It can in the form of a solution also, but using strips of litmus paper is more convenient. Right now, you can store it, you can keep it in your pocket also. So that is litmus paper. Red litmus turns blue. Red litmus turns blue in basic solution. That indicates a basic solution. And if a blue litmus turns red in a given solution, it indicates that the given solution is acidic. Is that clear to everyone or not? Then later on, you have got one more type of paper that is called as pH paper. It's a universal pH paper. This is a pH scale, by the way. It's different from, don't get it confused with the litmus paper. Okay, it's a different thing. This is pH scale. So you would be having a universal pH paper and you dip it in a given solution. If the color of the paper were to change to red, pink, or dark orange, light orange, or yellow, or light green in color, so thereby that will indicate that the given solution is acidic in nature. Or if this universal paper that is dipped into a given solution, if its color changes to dark green, then to light blue, then purple, then blue, and then magenta color, that is purple color, that will indicate that the given solution is basic in nature. Are you guys understanding this one or not? Please tell me. Abu, you got it? Priyanka?
Sir.
Hmm? Okay.
That pH paper, how they make?
How do they make litmus paper?
By lichens?
How litmus paper is made? Obviously, it is made from lichens now. First of all, in fact, we can also make it at home. The procedure is not that much not much complicated. See,
Sir, how do you make?
You need to have the following substances. You need to have the cellulose of wood, cellulose found in wood. You guys know about cellulose now? CELLULOSE. Cellulose is found in the wood now. So you would require some wood cellulose. You would require some lichens, and you would require some other raw materials also. For example, you can require some other raw materials also. So what you are going to do, the step-by-step procedure is going to such that First of all, you will crush the lichens. Okay. First of all, you will crush the lichens, and then you will take a mixture of ammonia and potash, and then you will mix it with a mixture of ammonia and potash and allow it to ferment. Okay, now let me write it, otherwise you won't catch it. See, first of all, you will take litmus. Sorry, lichens, I mean to say. You will take lichens, then you are going to crush it. All right. After having crushed it, what you're going to do, you are going to mix it. Mix it with what? Mix it with ammonia
And potassium.
and potash. Okay. Here, what will happen? Fermentation will start to take place. After having mixed into it, fermentation will start to take place. All right, now. Now, after fermentation has taken place, whatever thing you will be left with, it will be blue in color. You will be left with a fermented substance, and that is blue in color. All right, now that is blue in color. Now, what you can do, you can mix it with chalk. You can add chalk to this. You all know about chalk, right? You will add chalk to it in order to obtain a paste. Addition of chalk to this fermented substance gives you a paste like structure, paste. And then this paste will be, later on, this paste has to be dried. This paste has to be dried, and then it has to be grinded into a form of powder. So far, you
Sir,
guys are getting it now. Yeah.
no, sir.
Sir, or else we can take the paste and then you can take a paper and then like dip the paper inside and then you will have strips.
See, in that case, now it will not be working in an efficient manner. That's why it has to go through this process. It has to be mixed with ammonia and potash, so their fermentation will occur in this. Then that
No, sir.
fermented substance, yeah.
No, sir. You are saying that you take the fermented substance and chalk and then you make a paste, right?
Yeah,
That
okay,
paste,
talking about that, yeah.
that paste, you can take a paper and dip the paper inside the paste and then you
That
can
can
make.
also be done. Yes, Abu, that can also be done. Okay, no? But usually what is done, chalk is added to it to make it a paste, and then it is dried. Okay, now then it is dried, and then later on it is added, it is mixed with paper. While like paper is dyed, no, you have colorful papers now, so dye is added into colorful paper. For example, you look at your textbooks, so it is colorful because different colors are added in it. So now you have now this dried, and then this is in a powdered form. So this powder can be used to dye the paper. So thereby you have now got a litmus paper. Like whenever if a wall is painted, so you have paint in the powdered form also, no?
Yes,
Yeah,
sir.
you right now. So in that manner, you guys can understand it. Is that clear to everyone? Although normally you might not be getting all these required substances like ammonia and potash. You might not get these things in the market. But anyways, that's the procedure which you guys can use to make it. So we had this example of litmus paper. Keep this thing in mind. Litmus litmus paper is one of the example of natural indicator, and it is obtained from lichens. And litmus is available both in the form of solution and in the paper strips, namely red litmus and blue litmus. We have learned about how it basically helps us. Okay, there are some there are some everyday things that you would see around yourself. For example, you guys tell me, if you were to have a tap water and you test whether it is acidic or basic on nature. So say for example, you have the red litmus paper and you have the blue litmus paper. Or Yeah, red litmus and blue litmus paper. What would be the effect of tap water on red litmus paper? Yes, do tell me. Hello.
Sir,
Yeah. What would be the effect of red litmus tap water on red and blue litmus paper? Neutral. Tap water is usually neutral now. It is neither acidic nor basic now.
yes,
Yeah.
sir.
So no
Yes.
change in this one, no change in this one. So conclusion is that it's a neutral thing. Or now let us
Sir,
say that, yeah,
sir, uh, uh, tap water or bottled water, sir, all of them are neutral.
exactly. All of them are neutral. Okay, now unless you add something to it that can make it acidic or basic, all of them are neutral. Now
Sir, like
further you tell me, yeah,
sir, like soap.
like soap water is basic. Okay, now if I were to give you a detergent solution, then
Sir,
what change you're going to observe?
Uh,
red.
sir, red.
Red changes to,
Red changes to blue.
so this one changes to blue. So what do you conclude from this? What do we conclude from this, Priyanka and Abu? That it's a basic substance now.
Red, it is a
Yeah.
yes, sir.
Okay, what can you say about cold drinks? What can you say about cold drinks? Aerated drinks, normally Coca-Cola, Sprite, etc.
Blue to red.
That will change from blue to red. So that indicates what?
As.
That is an acidic liquid, right? Good. Or say that if you were to have a vinegar, then in that case, what will happen?
Sir, no change. I mean, yeah.
No change. Vinegar is basically acetic acid, no?
Yeah.
Like in the red one, there will be no change. That is correct. And here,
Red.
it changes to red. So thereby it is a acidic substance. Okay. Or baking soda solution. What about that?
Sir, color change in red to blue.
Color changes to blue. Very good. Baking soda. Thereby that is
Basic.
basic substance in nature. Okay. Have you guys ever heard of this? Like um, about this thing. We call this as milk of magnesia. Have you guys heard of this milk of magnesia?
No,
Yes,
sir.
sir.
It's a medicine that is used to treat constipation. If someone's suffering from constipation, so milk of magnesia is given. Milk of magnesium is basically a base. Okay, now milk of magnesia is a base, and it is used to treat constipation. So basically, magnesium hydroxide. It's a medicine used in the treatment of problems like constipation. Keep that thing in mind. Okay, now. So milk of magnesia. What would be the nature of this? Yes,
Magnesia.
milk of
Hydroxide.
magnesia. Hmm. Yes.
Sir, magnesia hydroxide. Not
Yeah,
sure,
that
sir.
is magnesium hydroxide. My question is, it will be changing red to blue or blue to red. What will happen here? It's a
Blue.
basic substance now.
Yes, sir. Blue changes to blue.
Blue changes to red changes to blue. No.
That's a sir. That's a right
Yeah.
one.
Okay. Okay. My bad. So red to blue in blue litmus paper, no change. Hence we conclude that this is basic right now. Or for example, you have lime water. What about that one?
Sir, it's basic, right?
It's basic again. So that again changes to blue. No change observed here. That is basic substance. So hope you guys are getting it. So that's how we use the litmus paper. Apart from litmus paper, also there's one more such natural indicator. You have China rose petals. How many you have seen this plant? China rose,
Sir, it's like hibiscus, right?
hibiscus. Kind of looks like this. China rose plant kind of somewhat looks like this, but it is slightly different from that, I believe. I might have taken this image mistakenly, I believe, or no, actually, this one is an example of China rose. I think China rose plant. Okay, now
Yeah,
this one is
China
China
looks
rose
like,
plant. Yeah,
sir, China rose plant is like that only.
yeah, it looks like that only. Yeah, exactly. This looks like that. Okay,
Is
now.
that
Mhm. So let us understand what is its use. Okay, now how do we use it? How does it work basically? So we are not going to directly use it and not directly dip it into acidic or basic solution. First of all, we will make a solution out of it. Not solution, basically what you can do, you can take some China rose petal and keep it in warm water. After having kept it in warm water, it will start to release some pigments in it. So thereby now you have the indicator. China rose petals indicator is ready. We basically use the petal of this flower. Petals, you guys know, the colorful part of the flower, that is petal. So you extract this, you dip it in warm water and a colored solution is obtained from that. Now this colored solution is used as an indicator to test acidic or basic substances. See what is going to happen over here. Say for example, um, if you were to dip it in acidic solution, not usually the color is a bit pink. It's pinkish in color. It's pink in color. What what would be the effect? For example, if you were to dip it in a solution of hydrochloric, say that you have a hydrochloric acid solution. So in this, if you were to drop some China rose petal water, if you were to drop this indicator into this hydrochloric acid, thereby what will have happen? The color will change. Obviously, the color will change now.
Yes, sir.
So the color will, from this light pink, it will turn into dark pink. It will turn into dark pink. So if the color of the China rose petal from light pink turns into dark pink, thereby that is an indicator that the given substance to be tested, it's a it's a acid. Okay, na? Now, if the color were to change into green in color, for example, if you were to use calcium hydroxide, here it changed into dark pink, let's say. From light pink, it have changed now. Let us use this color to make it, to show it a bit darker. See that you were adding few drops of it. This is pink, and as soon as the drops went into it, the color changed to dark pink. Now
Sir,
say that, yeah,
in the image, it looks like red.
okay, it kind of looks a little bit red. Okay, let's make it pink then. Now, okay,
No, sir, not in that. It's like in the test tube.
okay. In this one, yeah, this image is not giving you a very proper depiction of it. Okay, no. In this one, it might look like that. Say that you will have to ammonium hydroxide or calcium hydroxide. What are these substances I'm taking name of?
Sir, can you repeat again?
Calcium hydroxide or ammonium hydroxide. What are these substances? They are bases now.
Yeah.
Calcium hydroxide or magnesium hydroxide. Now, in this, if you were to drop this indicator, thereby the color will change to green in color. The color will change to green. So that is an indicator of a basic substance. So that's how China rose works. So plants or plant parts contain useful chemicals that are used for testing an acidic or basic property of a solution, and they are natural indicators. One such example was this China rose petals. Apart from this, also you have example of turmeric, you have red cabbage, you have grape juice, you have turnip skin, you have curry powder, you have cherries, beetroots, onion, even tomato. Right now, normally we learn, you might have learned about few things only, but you have so many such examples of natural indicators. Is that clear to everyone?
Yes, sir.
Okay, now let us learn about the turmeric also while we are learning about this. Turmeric, all of you already know, I believe that from this image itself, it is clear. In a
Yes, sir.
basic solution, the color will change to reddish orange, while in the acidic solution, it will retain its color, it will remain yellow. That's why you have a common, it's common that if some food were to fall on your clothes, if there's some food stain on your clothes, so thereby what will happen that as the cloth is washed, so thereby the color changes to reddish orange. Have you guys observed that? Yeah,
Yes, sir.
No.
not observed that. Okay, okay,
Yeah.
but that happens. Okay, no. So we have discussed about the natural indicators. Next, we are going to discuss about some synthetic indicators. All right, no. Next, we are going to learn about some synthetic indicators. What are some examples of synthetic indicators? So we have some common examples. We have phenolphthalein is there. You have methyl orange. You have methyl red also. These are some of the common examples of synthetic indicators. Two most common examples are phenolphthalein and another one is methyl orange. Okay, let us learn about them. Let us learn about how do they function. Okay. Have you guys studied about these indicators in your school?
Yes, sir.
Good. Explain how phenolphthalein works. Any idea regarding this?
Sir, in acid, actually, it is colorless,
Okay.
and in base, it's pink.
In bases, it is
Pink.
pink. Correct. Okay. No?
Met in
Mhm.
acid. Sir, I know in base.
What about base? Yeah, answer that
Go ahead.
one. In basic solution, methyl orange turns to yellow actually. Okay. No? Okay. So let us start from this phenolphthalein. Let us learn how phenolphthalein works. How phenolphthalein basically works. Okay. No? So talking about this phenolphthalein, what will basically happen as by the way, this comes in the form of solution. This comes in the form of solution. And apart from this indicator, it has got some other uses also. Phenolphthalein popularly is known as an acid-base indicator. It will be colorless in acidic solution, but it will turn pink to red as the solution becomes alkaline. So you have taken few drops of alkaline and you add into a given test tube. So if the color of the solution in this does not changes, it remains colorless. Well, I mean to say that it does not show any change in it. No change in it. So thereby, what do you infer from this? What do you conclude that it's a acidic solution now, right now? So this is acidic solution. Or you can do opposite also. Like if you were to in this test tube, you have taken some naphthalene. You have taken some phenolphthalein and say that you have taken some lemon and you are dropping some lemon drops, lemon juice over here. Okay, no? Lemon drops you're dropping over here, and this is phenolphthalein. So lemon is acidic in nature. It consists of citric acid. So there will be no change in it. It will remain colorless. Usually phenolphthalein is transparent. It looks like water. Getting it now? That's why we say that it is colorless. Next, as you will be dropping a basic substance into it, the color will change to pink or red. Also, here we have used the term alkaline because only some bases will be soluble in it now, right? Not all the bases are soluble in water. The one that are soluble, they are called as alkaline.
Yes, sir.
So that is how phenolphthalein is used. Now let us learn about how methyl orange is used as a acid base indicator. Okay, now. So methyl orange is usually used as a pH indicator that is used in the titration also. Titration is, by the way, a concept that we'll be studying in higher classes. So as of now, do one thing, just forget about this term. It is usually a popular pH indicator that shows the pH value. By the way, you guys have learned about pH scale in your school or not?
No, sir.
Not yet.
No, sir.
Abu, you also haven't learned. Is
No,
that in your syllabus or not?
sir, I don't know.
Okay, okay. See, methyl orange, as the name speaks for itself, it is orange in color. It will be used in laboratories to determine if a solution is acidic or basic. In acidic medium, this methyl orange will give red color. This orange color will turn to red in an acidic solution. Getting it now? What I'm trying to say. It turns into red in an acidic solution. While it will give yellow color in a basic solution. In a basic solution, it will be giving you yellow color, thereby indicating whether the given substance is acidic or basic in nature. That's the thing about it. Is that clear to everyone?
Yes, sir.
Okay. No?
Yes.
Sometimes apart from red, it might give a little pink color also. So that can also be observed sometime. So hope you guys are getting it. And both of them are examples of synthetic indicator. Keep that in mind. That are man-made indicators. That not directly obtained from nature. It has to be processed, goes through lots of processing, and chemicals are added into it. Now, in the beginning, I did told you about some olfactory indicators also that they might lose their smell or might retain their smell in some acids or bases. So they are olfactory indicators. Olfactory indicators are the substances whose smell changes when they are mixed with an acidic or basic solution. For example, onion in an acidic substance, their smell is not lost. Not you won't be using directly an onion, but you would be using onion juice. You would extract the onion juice, huh, and then you can use it as an olfactory indicator. Olfactory, by the way, refers to a smell. The term itself refers to a smell. Okay, now. So in the acidic solution, the smell will remain, while in the basic solution, it will lose its smell. So that's how it is used. Talking about vanilla extract. Vanilla extract, same thing is seen for vanilla extract also. In acidic, it will remain, the smell remains, while in base it is lost. Same thing happens in the case of blue whale also. Is that clear to everyone also? Is that clear to everyone?
Yes, sir.
Yes.
Okay. What do you know about vanilla extract? Have you heard of this vanilla extract? What is vanilla?
Sir.
Why
No,
it is used?
It's from a vanilla plant bark, and then
Hmm.
the extract is like you put it
Hmm.
inside a jar, and then it's for a year, and then
Hmm.
it's you can take out the extract of the vanilla.
But in that jar, it is not kept empty now. It is mixed with water and ethyl alcohol. Okay, no? Like you can take the vanilla extract. How do you do that? How do you do that? First of all, you will obtain the vanilla beans or vanilla stem or vanilla beans. You will take it from that plant, and then you will soak it in a mixture of water and ethyl alcohol, and you will leave it for a long period of time. And after some time, it will start to give a very give a vanilla flavor. The largest use of vanilla is for ice cream preparations. Hmm? It is used in yogurt products also. Vanilla, particularly, it is used in ice cream products. It is used in uh, yogurt products also. There also it is used, and it is added to soft drinks also. In some cases, it is added to soft drinks also. Even in alcohols also, it is added. So hope you guys are getting it. And it has got a sweet taste. It has a very sweet taste. Okay, now. So this is olfactory indicator. Hope you guys have understood that. If there's any question from it, please do let me know.
So what is vanilla?
Sir,
Yeah.
sir, for the turmeric,
Mhm.
uh, for like rather than adding paper, can we add a tissue paper? It would
See,
like
tissue paper.
so like like the water, it would be soaked more
Huh.
so then you
But
can see a result.
Mhm. But the problem with the tissue paper is, na, as soon as tissue paper gets in contact with water, it starts to break into very smaller pieces. It disintegrates. Uh, while in that case, you will have to use a better quality of tissue paper. A tissue paper that has to be relatively more thicker. Relatively, it should be thicker. Okay, no?
Sir, it doesn't break. For me, the tissue paper won't break.
Okay, okay. So if you have a good quality of tissue paper that is thicker, then it can be used. Okay, no? Rinka, you were asking about vanilla, right?
Yes, sir.
See, vanilla is used as a flavor in different things. It is used as a flavor, not just flavor, because it has got a very subtle sweet taste. It has a subtle sweet taste. So vanilla beans are extracted from the plants. Vanilla beans are taken from the plants, and vanilla stems are also taken. It is stored in water and ethyl alcohol for a very long period of time, and slowly it starts to release the vanilla smell. A very distinct smell is coming out of it, and then it is used in ice creams. Have you not eaten vanilla? You might have eaten vanilla flavored ice creams, huh?
Sir.
Normally get to hear this term vanilla flavored ice creams.
No, sir.
Like, no, that's usually not common to hear. Like vanilla flavored ice cream, that is very common. In fact, the
Yes.
largest single use of vanilla is in ice creams.
Sir,
Okay,
not
now.
in my place. There is no vanilla ice cream.
Oh, okay, okay. That's why you might not have heard of it. Okay, now. It is used to add
Yes,
flavors
sir.
also, like
I've
in
heard of it, but then
cocktail.
I have not never tasted it. I have
Oh,
just
okay,
ice cream. I have tasted the vanilla, but
okay, okay, okay. No issues. Okay. By the way, no need to learn this. This might have mistakenly got into this. Okay, now. Also, neutralization reaction, we have learned about that in the class. What is neutralization reaction? What were some of the uh, uses, some of the neutralization taking place in our life on a daily basis? We learned about that also. We learned that how, after having tested the pH level of soil, we found we find that if it is too acidic or if it is too basic, so thereby by proper treatment, it can be brought to normal state. It can the pH level can be lowered or it can be increased to neutral.
sir,
Yes.
sir, how do you check with how can you check with this
This.
Like, sir, how can you check with any sand?
I didn't get it. How can we check it with any sand meaning?
Sir, like dirt, like sir, as you said that like
Okay,
farmers
okay.
they
Mhm.
uh, they check the pH level of the dirt.
Okay,
Uh,
so how do they do this? Now, that's the question here. See, what basically they are going to do, they would take some sample of soil, they would take some sample of soil, and then they will mix water into it. So you have a solution ready. Then they will be dipping the pH paper into that solution of sand or silt or soil and water. uh, And whatever the color changes, so then they will be able to find the pH value. So they have to add water to the soil. Okay, no? Is that clear or not?
yes, sir. Sir, I think that uh, sir like is salty water acid?
Salty water acidic. No, salty
Yes, sir.
water is not acidic, it is neutral now. Salty water is not acidic. It is having a pH level around 7. So salty water is neutral. Getting it or not? So salt water itself is neither
Yes,
acidic
sir.
nor basic. But sometimes we have observed that it can be slightly basic in nature. Slightly. Okay, no? I'm saying that if you were to look at the pH scale, I guess I have this diagram. Let me take a diagram of pH scale, image of pH scale. See, pH scale, you guys know, they are reading from 1 to 14 on pH scale. The reading 7 shows a neutral value, pH scale. Below it shows you a acidic substances. Have a look at this one over here. See, this is a pH scale. This is a pH scale, okay now? Now, using a pH scale, you can find the strength of a given acidic or basic substance. Also, you can find whether it is acidic or basic in nature. That can also be found, but you can also find what is the strength of it. What is the strength of that acid? Like using the litmus paper or using methyl orange or phenolphthalein or olfactory indicators, you were only able to find whether the given substance is acidic or basic. Isn't it, Priyanka? Isn't it, Abu? But do we have any way to find out the strength, whether it is a strong or weak substance? Yeah? No. Okay, now. So thereby we have got a pH scale. pH scale. Potential of hydrogen, how much of hydrogen is found in it. You guys know that hydrogen will be found in more concentration in acids now. A strong acid will have more number of hydrogen ions. See, for example, you have hydrochloric acid. Hydrochloric acid is a concentrated acid. Concentrated acid means that it has high amount of hydrogen in it. Okay. So when you will dip a pH strip, when you will drip a strip of paper in order to check for this hydrochloric acid, the color will be orange in color. It will give you an orange color. That denotes that it has got a high concentration of high amount of hydrogen ions are found in it. Try to understand this. So concentrated acids have got more amount of hydrogen. Or let me just keep it simple for you guys. If you might get confused in it, like this topic is taught in detail in high classes. So let me just keep it very simple for you. See, the simple thing is that the strongest acids will give you orange color. Then as you move higher up, the color will start to fade. It will go to light orange, then turn to yellow in color. So look at gastric acid. Like gastric acid here is referring to hydrochloric acid that is released by your stomach. So gastric acid is a very strong acid and has a pH value of around 1. Lemon juice is also a strong acid and has a pH value of 2. Orange juice has a pH value of 3. Then tomato juice, black coffee, urine. So acids like orange juice, tomato juice, black coffee, or urine, they are weak acids. What are they? They are weak acids. Then acids like lemon juice and gastric juices, they are strong acids. Are you guys getting it or not? Priyanka,
Yes,
are
sir.
you getting it? You're getting this now, pH scale. Hmm? Now, furthermore, you have distilled water. Distilled water has a pH value of 7. If the color of the paper changes to this, it means that it shows a pH value of 7 on the pH scale. Seawater, seawater is saline now. Moments ago, I told you that salty water, namely like saline water, seawater, which is salty, uh, it is slightly alkaline. It is slightly basic in nature. So it has a pH of 8 or 8.1 like that. Okay, now so yeah, we can say that it is basic, not a very strong, but it is slightly basic in nature. Now, as you go higher up, you have bleach, you have soapy water. These are very strong bases. Getting it or not? Bleach, soapy water. So as you go higher up in this scale, then you will be having strong bases. While this one also, while milk of magnesia, baking soda, or seawater, or just up to seawater, they are weak base. Let me write it this side. These are the examples of weak bases, and these are strong. Is that clear to everyone or not? Hmm? Priyanka and Abu, did you guys understood about pH scale? Yeah.
Yes, sir.
So pH scale basically measures how acidic an object is. It basically measures how acidic it is. It does not shows whether it is acidic or basic. That's not the main function, although that is also shown by it. But it basically measures how acidic an object is and how basic an object is. Uh, Hope you are getting it. Also, um, we had several examples over here also, like the normal water that we drink, it is neutral. So a pH level of 7 shows you neutral. A pH level of 7 will show you the strongest bases will have a pH of 14. Strongest, I'm saying not a strong, I'm saying strongest. So strongest base will be have a pH level of this. Okay, now for example, caustic soda or liquid dry cleaners, the liquid dry cleaners that we use at home, what are they? Are they acids? No, they are basic substances. You might confuse it with acidic substance, but not dry cleaners, I mean to say this, drain killers, I mean to say, sorry, liquid cleaners, they are highly basic substances. A caustic soda, that is a very basic substance. Gastric juices or the zero. Battery acid has got a pH of 0. The battery acid has got a pH level of 0. So as you move in this direction, as you move from 7, as you move towards 0, the acidity increases. The strength of acids increases. And as you move from 7 towards 14, the basic property increases. Are you guys getting it or not?
Yes.
Both of you have understood it now? Okay. In higher classes, you will learn about full form of pH, like it refers to potential of hydrogen, by the way, or power of hydrogen. How much of hydrogen is found in the given substance? Like in these substances, more amount of hydrogen will be found. In acids, hydrogens are found. We have learned that. In bases, it will not be found. So on that criteria also, you can relate it. So we have learned about that. Then we in the while we were talking about acids, so there already we learned about the uses of this. What are the uses of acids? We have already learned that. So you have citric acid used in preservation of food, or carbonic acid is used in aerated drinks like cold drinks that you drink that consist of particularly carbonic acid is found in it. Acid is found in vinegar, which is used for the purpose of cooking. Sodium hydroxide, that is NaOH, it is used in manufacture of soaps. In manufacture of bleaching powder. You guys know about bleaching powder? Bleaching powder. How many of know about it? Yeah, no idea
Yes.
regarding this. Bleaching powder has got several uses. It has several uses. Like it is used for bleaching the dirty clothes in the laundry. It is used as a bleaching agent for cotton. In the textile industry, it is used. Like the cotton fibers that are obtained from the cloths, at that time there are lots of dust and dirt particles in it. So it has to be bleached, it has to be cleaned. So cleaning for that, it is used. Apart from that, it is used for disinfecting the waters also. You guys know earlier what people would used to do now, like if they had a well and the water of the well is dirty, so they needed to disinfect it. So they will put 1 kg or 2 kilogram of bleaching powder into the well water, into the well, and that will disinfect it. You can ask your parents regarding those, or your grandparents. They might be aware of this. Normally in villages, they will be doing this. Anyone of you who have got a village background or farming background? No. Okay. See, then it will be used as a foaming agent also in the fire extinguishers. So aluminum hydroxide, talking about aluminum hydroxide, it is used in the fire extinguishers. Aluminum hydroxide is used in fire extinguishers. So we have the following uses of acids and bases. We did learn about litmus, by the way. So there are some questions from this chapter. In the next class, we'll be dealing with the questions that are there in the chapter. If you guys have any doubts in the chapter or any questions, please do feel free to ask since we have finished the chapter today.